Hello and welcome everybody. Welcome to this event on how to enter the space industry in 2026. I'm extremely glad to have you all here. And without further ado, let me share my screen and let me dive into it. Thank you so much everybody for joining. My name is Ruta and I am the founder of Deep Tech Education. I'm very glad to see you all here, wherever in the world you're joining us from tonight, or this morning, or this afternoon. And I mean that literally. Looking at everyone who signed up for this event, we have people from all over the world. We've got people from UK, US, India, Canada, Emirates, Nigeria, Mexico, and so on. And everybody's in one room, and that tells you a lot already. Before I head over to our headline speaker, I wanted to take a few minutes just to talk to you about why this event even exists. So I will start with my personal story first. I have loved space all my life, and this part was not coming from anywhere, not a business decision. It's just been there all my life. But the last few years, I've spent working in edtech. And in that time, I've watched something that has really bothered me. A lot of my students, graduates who are very smart and capable and hardworking people, they kept struggling to find jobs in the tech industry. And everywhere I turned and all the conversations I had, people would just shrug and say, oh, it's AI, AI is taking all the jobs. But I refuse to believe that. And I still do. So instead, I follow the money and where it's actually going and who's actually hiring. And the answer I found was that venture capital is moving to deep tech, particularly over the last decade. What is deep tech? Then I asked myself. And I found out that it's space, defense, cybersecurity, robotics, quantum, it's clean energy, it's biotech. And it's essentially industries solving genuinely hard problems that are growing really fast and are crying out for people right now. And space sat right at the heart of it, which I'll admit made me very excited. So I combined the two, and the passion that I had for my own life and the thing that I actually know how to do really well. And Deep Tech Education was born. It is a bridge between industries with a serious skills shortage and people who deserve to know that these careers exist at all. Because here's what I kept seeing. When most people picture a job in space, they picture generally one thing, and it's an astronaut. Rockets and astronauts, that was the main theme. But the people who actually build this industry, the software engineers, the electronics and systems people, security specialists, the robotists, the project leads, they're almost invisible. So a lot of brilliant and capable people either don't look at this at all or look at the space industry and decide to themselves that it's not for them or that they're too late or they don't have a degree. Meanwhile, those same companies in deep tech industries are really struggling to find the skills that they need to drive the sector forward. That gap between how enormous this growing industry actually is and how closed the door looks from the outside, that's the divide that I built Deep Tech Education to bridge. So let me give you a real picture because the numbers that I found were staggering. First of all, the global space economy was worth around $630 billion in 2023. It is actually forecasted to reach $1.8 trillion by 2035, which is nearly triple. By 2035, it's expected to be roughly the size of the entire semiconductor industry and as woven into our daily lives as chips in your phone. And here's the part that most people actually miss. More than 60% of that growth is expected to come from space-enabled sectors that are outside of the launch itself. It's supply chains, agriculture, it's finance and transport and defense and retail and legal, you name it. All these industries make one ecosystem. So looking closer to home, and I'm based in the UK space sector employs around 55,000 people directly. In the United States, space jobs have actually grown strongly over the last decade, and salaries there remain well above the broader private sector average. And while the overall US job postings actually fell by 5% over the last year, space job postings went up 40%. So this is becoming not a niche. This is now one of the great growth stories of our time. Now, where it gets interesting for everyone on this call. You'd assume that an industry growing this fast is drowning in qualified people. It's the opposite, actually. In the UK, more than half of space organizations report skills gaps in their own workforce. And many say that applicants do not yet have the right skills. But here's the surprising bit, and this is the whole reason why I'm standing here today. The biggest skills gaps in space are not space-specific. They're not how to build a rocket. The gaps are in software, data, artificial intelligence, in cyber, systems engineering, electronics, stuff like radio frequency. Software and systems roles alone account for around half of all the open space vacancies. And electronics, systems engineering, and spacecraft operations are amongst the hardest roles to fill of all. So in fact, in the US space economy, the most common single job is software developer. And by one US government estimate, only a small fraction of aerospace engineers, roughly 1 in 20, actually work in the space sector. So the industry doesn't just need more aerospace graduates. It needs transferable skills from right across engineering and software, operations and management, and the skills that many of you already have. Electrical engineers, mechanical engineers, systems and structures engineers, software and data people, and project managers and testers. You just haven't been told that deep tech needs you. And it goes wider than engineering, in fact, much wider. Every satellite that goes up needs someone who understands space law and licensing. Every mission needs project managers who can hold complex programs together. And honestly, that's the most under-talked about shortages in the sector. As we send people further for longer, we need psychologists and human factor specialists who understand what isolation and confinement do to a crew. There are architects designing habitats, doctors working on space medicine, journalists explaining all of this to the public, finance people underwriting it, artists and 3D designers helping us to see it before it exists. I know some of you are in exactly those roles because I've read the forms that you registered with. So if you're sitting here thinking, I'm a lawyer, I'm a teacher, a project manager, or I'm medicine, this is not for me. It actually is. An industry heading for $1.8 trillion doesn't run on engineers alone. No industry runs in silos like this. And I want to say something to the two groups that are in here tonight, because I know you're both in this room. If you're early in your career or still studying, you're not too inexperienced. In fact, nearly a half of all hires in the US space economy are under 35. This industry is getting younger, not older, and the door is open earlier than you think. In fact, just last week, I spoke to a lady who's 24 years old and working on a Mars rover at Airbus. And if you've got 15 or 20 or 30 years behind you in another sector and you're wondering if it's too late, it's definitely not. Around 60% of vacancies are mid-career level, making experienced hires one of the sector's biggest recruitment bottlenecks. The experience you're worried is irrelevant is the exact thing they actually can hire for. So you're not starting from zero. You're starting from somewhere they actually desperately need. Take cybersecurity, for example. There are around 15,800 working satellites in orbit right now. Many of them are hard to update once they're actually in orbit. So the 2022 KA-SAT incident showed how a single cyber attack can disrupt satellite-based internet services right across Europe. The space cybersecurity market is forecast to grow rapidly this decade. And the industry itself reports a real shortage of people who can understand both cybersecurity and space, or robotics and autonomy, for example. As we stop throwing satellites away and start repairing and refueling them in orbit, demand for people who understand autonomous systems, robotic software, computer vision is climbing really fast. These are the exact areas that we need to focus on, because these are the doors that actually are open right now. So if you're thinking tonight about a move into the space industry, I want you to leave with one thing. You don't need to start over. All you need is a bridge. From the skills you already have to the industry that already needs them, taught by the people who actually are doing the work. Not theory, practitioners teaching the real thing that they've been working on for most of their lives. And I'll be straight with you about where we are. I am shaping this platform, Deep Tech Education, right now in real time. What gets built next is shaped by who turns up to rooms like this one today. And I'm actively engaging with industry leaders from a vast array of specialties. So when I say I'm building this for you, I mean people in this call tonight, specifically. I am here so you can tell me what you need. And I'm building it for the whole ecosystem, not just engineers, but because that is what the industry actually needs. So speaking of people doing the real thing, I couldn't be more honored today by who's about to join us, a man who needs no further introduction, someone who's spent 40 plus years at NASA working on human spaceflight, George Salazar, and someone who has spent an entire career at the very frontier we've been talking about. So let me stop talking and let me hand over to George.
Thank you, Ruta. I appreciate the introduction. And so let me dive into my presentation. So thank you for inviting me to give a short presentation about my, let's call it twist career, if you will, to get into NASA. And from making donuts to NASA career, I have to say that for the most part, my career was not a straight point A to point B like some people have done in the past. So my discussion points today are going to be related to my background highlights. It's going to be a short highlights. There's a lot of information in a autobiography that I wrote called From the Barrio to NASA, and in there entails more detail in what I have here, but perhaps in the future event I can talk more about my, let's say, trials and tribulations of going to NASA. Challenges coming to onboard at NASA. I'm going to be discussing some of the things that, let's say, I felt apprehensive about coming on board at NASA once I got hired on. My NASA project examples, I'm going to give a couple of them. And then NASA recruiting. I have to say that one of the things that I actually found very interesting was becoming a NASA recruiter, and it from the standpoint of what not only NASA was looking for, but other industries as well. And I'll share a little bit more about that in my presentation. And then something that I guess it was an observation in my part over the years was overlooked paths to a new career. There's a lot of folks out there that have incredible skills that they think they don't apply for the space industry, but yet they do. And so I'm just going to try to highlight that as well, and then conclusions. So here's a let's say here's a quote from Alan Sanders, who was I think he was a writer. He said, "Life is what happens to you when you're busy making other plans." And in essence, what he was trying to say was that you got to be adaptive in your career, in your life. you have to navigate uncertainty, and I had a lot of that in my life. And you got to embrace change, and you got to thrive in a dynamic environment. And these are the key elements that help you, let's say, navigate from where you think you should be, and where you think that, let's say, you're not going to grow, to an area that you say, oh my God, I should have looked at this in more detail, and I find out that I can do more than what I think I am expecting myself to do. So my road, and it's actually, it shows a straight line, but in reality, it was really a curve of a road. And so, obviously, I was born in the ghettos of Corpus Christi. I was not, let's say, from a prominent family, gifted family, a educated family. Be that as it may, I accepted that. But my dad brought a donut shop in Corpus Christi when I was 10 years old, and he taught me how to make donuts. And actually, that became my specific career, if you will, of making donuts. One of the things that I do want to point out in that donut shop was that my dad had suffered a heart attack, and I had to basically run the business at the age of 16 while going to school. And actually, that was beneficial for me in applying for NASA, and I'll say more about that later. I graduated from high school in the bottom 20% of my class. And so you say, oh my God, 20%, bottom 20% of the class, and you ended up in NASA. How in the world does that happen? Well, it happened for me, and I'll say more about that later. We moved to Houston because things were not doing well for our business. And so in Houston, Texas, I took on various jobs, construction, book sales. I was a stocker, and I went back to donut cutting. Donut cutting was actually my profession. And for the most part, I was making decent money. At that time, I was making somewhere around $180, $200 a week, American money. And so that translated to, if you look at it today, somewhere close to $2,000 a week in income. And sometimes I was working 2 or 3 jobs. And so I was bringing in quite a bit of money. But, I had to look at that and said to myself, well, wait a minute, I really need to make a change. I was dating at that time, my girlfriend that was still in Corpus Christi. And so, we talked about, let's say, our future, if you will. And I wanted to make a change, and I tried to. I tried to become a repair technician. I applied at a couple of companies, Xerox as well as IBM, and I failed their tests. I pursued return to college, but because of my low scores, 20% in high school class, I did not do well. And so I had a challenge trying to get back to school, and there was a junior college that accepted me on a probation basis. And so I exceeded their expectations and graduated with Associates of Electronics Technology. And I thought that was going to be the extent of my education. But, from family members, my wife and others, they encouraged me to keep on going, if you will. And so I went on to the University of Houston. And while I was working at the University of Houston, I worked 2 jobs that eventually would help me get a job at NASA. One of them was electronics repair technician at the Cannon Calculators, and the other one was a internship at a seismic exploration company called Geosource. And interesting enough, when I was applying for internships, I did apply for NASA for an internship, but I was rejected because of my low GPA scores at that time. And then I was approaching graduation, and I interviewed with several companies, including NASA. And long story short, of course, a lot of this is in my autobiography, but I chose NASA primarily because not only because of the challenges, but secondly because of the stability of working for the government. And then I graduated with a Bachelor of Science in Electrical Engineering in a 2.72 out of 4.0. You can see that it's not all that fantastic, but Mr. Brown actually liked the experience that I had, because that's one of the things that NASA looks for is experience and working with people. And I'll say more about working with people later in my presentation. So I came to work at NASA as an entry-level engineer. All right, so challenges coming on board at NASA. All right, I was dealing with the imposter syndrome. Okay, basically, I felt I didn't belong there. I came from a family that had no education. I lacked self-confidence in myself. I had a fear of failure, competitive culture. I mean, there were some people there that had degrees from some highfalutin universities, MIT, Purdue universities, to say a few. And so I felt like, my gosh, I don't belong here. But I found out later that it's something that's self-imposed on a person, that the imposter syndrome, can be overcome if you start to look at what your capabilities are. I was learning new technical terms and technology. I was learning space electronics design processes when I was going to school. The design process was very simplistic, but at NASA, the design processes were quite involved. But the important thing was for me to search and ask questions about what is this design process that NASA is looking for, and learn about it. And that's the important thing, is to that I think I came away with early on, was not only to let's say ask the right people for questions, but know where to look for that information. And so I used to spend a lot of time at the NASA library learning about the NASA's electronic design processes and understanding engineering disciplines. Oh my gosh, structures, thermal systems, power systems, materials, radiation, electromagnetics, human factors. A lot of this, I was visiting people from all over the center in terms of understanding what that all entailed, in order to get a better grasp, if you will, of what it took, to develop human spaceflight systems. And of course, one of the biggest things that I guess I got blindsided on was learning soft skills. It was a huge challenge, and I'll say more about that later, but I can tell you that soft skills is equal or more important than technical skills. All right, so one of the projects early on that, let's say, I was assigned to, and I don't know if it was I was assigned to it to either weed me out or to see how well I could do, but I was responsible for developing a space flight project, for the space shuttle program, which was called Voice Command System of the closed circuit television cameras. At that time, voice control was a early, let's say, early innovation, if you will, in technology, and we wanted to see how well that could work in space flight. So I basically became the project manager, systems engineer for the space shuttle program. or at least for the space shuttle closed circuit television camera voice command system, and to investigate how well and the feasibility and utility of voice control would be in a space environment, which is can be quite different than here on Earth. And there were two projects. One was first the STS-41, which was more related to let's say speaker-dependent systems, which was very early technology. And then later, STS-28 was more related to, let's say, adaptive speech recognition technology. That project, the second one, became, let's say, an opportunity to exercise my critical thinking skills, my creative skills as well. So one of the things that I think was a big factor in the voice command system was my introduction to systems engineering. And systems engineering is a big thing at NASA, but I have to say that it's not only NASA, but other industries as well, is to understand how developing a system from a holistic standpoint is critical to ensuring a successful system. So here's a video that I think Ruta can play out. It's basically the demonstration of the voice command system.
Up here for the last several days in space, and we thought you'd like to see how it's been working for us. George Salazar and his crew down there at the Johnson Space Center have put together a system that allows us to control the cameras without using our hands. We can just use voice commands to talk to the cameras. So here's a quick demonstration on how they work. Voice command, activate.
Select the monitor, then a camera.
TV1, Delta. Action.
Action.
Right. Stop. Tilt up. Left. Stop. Right. Stop. Change rate. Tilt down. Stop. Change rate. Tilt down. Stop. Right. Stop. Too much. Too much. Too much. Zoom in. As you can see, it's a great system, and we really like it.
I have to say that that voice command system entailed quite a few people, a lot of lessons learned by the seat of my pants, if you will. And so I was very grateful for that, because actually that was a big launching pad for me. So continuing on with another project, or at least area of my career, late in my career, was being the human-computer interface lead. And so I became the NASA lead for the commercial crew program, working with SpaceX on the touchscreen systems that the Dragon had. And touchscreen is new technology for space applications, and so I had to work with them not only in terms of the technical aspects, but also regarding to the human factors aspects of it. And then in the last few years of my career, I was working the Artemis human lander system, not only with SpaceX, but also Blue Origin. And I was working displays and controls. I was working lighting. Interesting enough, lighting is a critical factor, especially in deep space missions, because the circadian rhythms can be altered because of the lack of lighting or sunlight as you go further and further away from the sun. And of course, audio is somewhat critical in communications, as well as imagery. And that was also something that I was involved with. But more so, the human factors interaction model. I was not an expert in human factors engineering when I first started at NASA, but I became to learn more and more about it. And it became critical to understand how human factors factor in into a successful interface of a system. And it was something that I had no clue about until, I started to get involved with it. And let's say I was very receptive to learning more and more about the human element in terms of capabilities and limitations in operating systems. And you think about some of the human factors aspects of why airplanes crash and cruise ships collide with other cruise ships. Human factors basically tells you that if you're not designing the system correctly based on the human capabilities, you're prone to have accidents.
George,
One
sorry
of
to
the
interrupt
things
you.
that I want to say that, oh my gosh, this was a eye-opener for me was I signed up to become a recruiter at NASA, to try to bring in university students. And it was an eye-opener for me because I got some very limited training on becoming a recruiter for NASA. Look for their GPA, look for the classes they take and stuff like that. Okay, that's fine. But talking to some of the recruiters at these recruiting stations, Lockheed Martin, Boeing, Northrop, and some of these other companies, they were looking for beyond technical, which was an eye-opener for me. So the technical skills, you look at engineering, programming, data analysis, problem solving, domain knowledge, but the thing that they instilled on me was saying you also need to look at how well they work with people, communications, teamwork, adaptability, critical thinking, leadership, initiative, and curiosity. These are some of the things that actually I encountered, but I was not really aware of it early in my career. So in the recruiting effort, again, the bottom line on this chart, there's a whole lot of information, but it was an eye-opener for me to understand that it's not just technical, but it's also soft skills. And so when I go to the next slide, hopefully you can see the lack of soft skills contributing to failed projects. You can see this is the fishbone diagram of what can cause project failures: communications, team skills, collaboration, leadership, tools, and adaptability. So let me share with you a couple of, let's say, examples of what I experienced. And there's a lot more, but in the sake of time, I don't want to get involved with more detail. Communications, ego interference. There was a project I was involved with that with a shuttle upgrade, cockpit avionics upgrade. And there was a specific, let's say, computer system that was required in order to upgrade the space shuttle communication systems to the astronauts on the displays. Well, that card required a lot of high performance, time critical computing. So it was assigned to a particular individual that had 25 successful projects in the military sector. So fast forward, we were getting continuous updates on how well this upgrade was going, because it was critical for the shuttle cockpit avionics upgrade. And so this particular engineer from this particular company kept saying that everything is going hunky-dory and, et cetera, nothing's wrong. Well, come to find out, when we came to critical design review, a formal design review, he basically had to, as we call, fall on his sword and say, I'm sorry, I cannot meet the requirements of the design. And that was a major, major setback for NASA, at least for this project. It cost us somewhere in the vicinity of 6 months of delay, and somewhere about, in a vicinity of $500,000. So what happened? It was an ego thing. He thought he was very good, and obviously he was, but failed to understand his limitations. So the important point here was a soft skill in terms of ego interference. And the soft skill is the form of lack of communications between the manager that oversaw this engineer and that manager communicating back to NASA. The other thing was leadership. Leadership, I was involved with a project that we had a tyrant manager. Basically, he basically crapped the whip, if you will, on everybody, and wanting to make sure that things happen the way they're supposed to be. And when I approached him and said, these are not things that are going to work very well, he did not like that. And so, long story short was, we became into a disagreement with a person that thought they knew technology, thought they knew how to develop projects, versus me, that I had the experience. And so we became basically on different train tracks, and I left the project. And I understand that it was detrimental to the project, but that's what happens when you have managers that basically are tyrants and trying to, let's say, not understand other people's view, not understand their capabilities, and basically looking at their own perspective. The other thing is, and this is something that hopefully you guys can see, but I came across, I started to reflect back on some of the people that I worked with over the years. And so I worked with a nuclear engineer that became a real-time software programmer, a physicist that turned a robotics engineer, a plant chemical engineer that turned to one of the best Apollo systems engineers that the program had. There was a Houston architect. They used to design buildings for Houston that turned into a NASA human factors engineer. And then there's engineers and scientists and doctors that turned to astronauts. And this is important because, becoming an astronaut is very challenging. And so, the engineers and scientists and doctors that apply for becoming an astronaut sometimes have to wait years before they actually become an astronaut. There's one that we actually became good friends with, Clayton Anderson. It took him 14 years before he finally became an astronaut. So you sometimes you have to be diligent, you have to be dedicated, and stay focused on what you want to pursue. Now, my next slide is observations of overlooked paths over the new spaceflight career. And so you can see here on the left-hand side, there's electronic design engineers that are important for aerospace sector as well. Mechanical engineers, and they're also important for aerospace sectors. For electrical and mechanical engineers, the important thing is not so much, you have the core skills, but also you're going to learn the the technology and the processes for working in the space sector. Cybersecurity and software, that's a biggie right now. Aerospace sector needs cybersecurity software programmers, especially in AI, but also understanding the limitations of AI is important. Experienced tech technicians with good understanding of electronics test equipment. The whole area of test technician is a huge area, not only in aerospace, but other areas as well, including commercial aerospace, as well as cruise ships and things of that sort. Project management is also a biggie. You got to have people that understand what it takes to plan, time management, dealing with requirements and development. And so you got experience in that. That would be beneficial for the space industry. And then finally, administrative coordinating activities is, in the space industry, you need to keep projects and organizations process moving forward. And so those skills that you have in the commercial sector would be beneficial as well in the space industry. And so why is it easier to get into the space industry today? I'm not going to talk about this whole thing, but basically there's over 10,000 active space companies worldwide, from satellite operations, Earth observations, communications, launch, space, space research as well. And so it's just an incredible market out there that's begging for people, to apply and perhaps use your knowledge that you have from previous experiences that would be beneficial for space applications. And so in conclusion, an observation is generally one's career and journeys are unplanned and unexpected. And that's what happened to me. And the trick is to cultivate that growth mindset to embrace those challenges and persisting in the face of setbacks, and viewing those setbacks as an opportunity to learn and grow. And every experience and setback that I encountered led me to NASA. Adaptability, that's huge. It means to visit your belief system. Your belief system is basically your fundamental understanding of what you think is to be true. And those things that are fundamentally you expect to be true is where you come to expect things to occur that basically go back to your belief system. And from those expectations is your attitude and how you believe. If you believe that you're not good at math, you come to expect to be bad at math. And what's your attitude? You hate math. So looking at beliefs, your expectations and attitude, and reflecting on those become critical, especially if you're trying to change careers. Grades don't measure what you're capable of accomplishing. I'm an example of that. Imposter syndrome is self-imposed. As I figured out, I thought I couldn't do it, but I basically wanted to show that I could do what I didn't think I could do, and so that is something that you have to look at if you're trying to change careers. Is that don't think that because you're a software programmer for a little company that you cannot come work at NASA or come work at ESA or come work at SpaceX, because your soft programming tool is or capabilities is actually a critical core skill that can grow in another company. And it's important to keep moving forward. And I can't emphasize this more and more. I did this. I kept moving forward. There were times where I wanted to give up, especially at the university, but I kept moving forward and continuously evaluate the technical and soft skills and determine your gaps. I did that during NASA. I first started off at NASA as an entry-level engineer, but I continuously evaluated my technical skills and more so my soft skills and try to develop those. Not only learning about them, but applying them. There's a big difference between learning and applying. And I encourage you, if you have not applied soft skills in a real environment, it can be a challenge. And then one of the things to look for in your resume that is a huge, huge advantage is projects that you have done from start to finish. Some of the people that I talked to when I was doing recruiting is that they were looking for people that had the capability of taking a project from the beginning and going to the end and making it successful. So something to look at as well. And it doesn't have to be a huge project. It can be a university project for sake of argument. So I think with that ends my presentation, and I'm going to stop share and go back to you guys, Ruta.
Thank you so much, George. I'm sure I speak on everyone's behalf, but it's been such a pleasure and such great insights. Thank you so much once again. We've got a few questions. So what I'll do now, I'll allow people to unmute themselves. And if you could raise your hand, we'll take some questions from the live audience, and then we have a few in the chat as well. So we'll get to those in a moment. Okay.
Okay. Oh gosh, there's I just tuned into the chat session.
Yeah.
And oh wow.
Okay.
Oh wow.
So George, let's see. I can see Caroline is raising her hand. So Caroline, I guess you're going to address your question that you posted before.
Yeah, it's easier for me to talk it through. Hi, George. Thank you for taking us through that. That was so informative, really, really useful. I work in the tech industry at the moment in the UK, and we have gone through waves of mass unemployment due to AI. Everyone's on the bandwagon of AI is coming for your job. Everyone's trying to make sense of it. So what I'm seeing is an opportunity for people who are highly skilled mid-career to transition into space. And my particular speciality is product management. So it's at that intersection between tech and commercial and user needs, which I think a lot of the downstream applications in tech are in need of. I mentor founders on the UK Space Agency, and I see brilliant technical people, but really struggling with the commercial side of it. So I can absolutely see the opportunity there. I think the two questions that I had were one around the different languages that both industries speak around the skills and the roles and what they call them. Because in tech, we call it product management, and in space, you call it program management, but there's a lot of overlap in the skills that are required. So how could we bridge that? And the second part of the question is about the cultural bridge, because tech has always played a bit fast and loose with shipping products out to market, you know, the whole Silicon Valley move fast and break things attitude. And it's a very open culture in tech, whereas my limited experience so far in space is that it's a little bit more closed, a little bit more conservative. And I understand that because of its history in government and military and the need for secrecy and protection there. But I almost see like a culture clash as well as that language clash potentially between those two industries. So I'd really love to hear your thoughts on how we might be able to bridge that to make it easy for mid-career transitioners to move to space.
Yeah. Okay. So, first of all, AI, I have some reservations about it. it can be good and bad. You know, we here at NASA, we've been using AI for a few years. Interesting enough, JPL actually has Jet Propulsion Laboratory. JPL has been leading some of the efforts associated with AI in terms of the Mars Perseverance rovers. But the thing is that one of the things that has been a challenge for space applications in AI has been the verification and validation of a system that keeps changing over time. And so, that's something that when you deploy a system, you're first verifying that system is going to do what your verification requirements or your requirements are going to basically tell you that you have met the requirements or not. And so for AI, it's somewhat of a challenge because AI initially you say, okay, we verified that it can do this, but wait a minute, it's starting to change over time. How are you going to deal with that? And so JPL has done a great job in terms of basically providing not only AI, but also an assistant to overlook AI to make sure that it's not misbehaving. Because one of the things that AI can happen is that it starts to diverge, if you will, in how it was developed based on the data that it had acquired. So that is a huge difference between the commercial sector, because the commercial sector, they say it's not a big deal to say, oh my God, okay, so this is not working, we're going to change that. No big deal, and so we can compensate for that. But when you're working with deep space systems or systems that are going into deep space, it's not that easy, and so there's this big difference and disconnect and gap between the commercial sector in AI and the space industry. However, understanding what the limitations are in terms of the gap is important as far as the developers are concerned, because now the developers can come up with a compensation, if you will, of how to, let's say, keep that AI system in check, if you will, just like JPL is doing. But it's very costly, and that's one of the things. The commercial sector is in the business of making money, and so they're trying to keep their costs down. But that's something you have to look as a trade in terms of what the application is of how AI is being implemented, and what's the criticality of it, and what are the ramifications if this system goes south on you. That's something that I think we're going to be, let's say, struggling with, for a few years, especially more so in what I call safety critical systems, aerospace, space, even cruise ships are safety critical, believe it or not. There was a cruise ship that collided with another cruise ship that killed a few people many years ago. And so, you look at, those kind of applications that you got to be cautious with.
Thank you, George. Yeah, I'm taking from that the way that the tech industry is using AI is less safety conscious than space for very, very good reasons. Thank you for that.
Yeah, you're welcome.
Thank you, Caroline. So I see another question, and I can see Ray or not have a question.
Yeah, I'm halfway through a computer engineering with robotics course, and I've kind of just realized I do want to switch up into something more astronomy or astrophysics based. Now I have a master's in mind, but do you have any idea how I could kind of make that shift from here?
Okay, so you're majoring in computer engineering and you want to switch to astronomy and astrophysics? Is that, was that the question?
Yeah, I'm doing computer engineering with robotics, and I kind of want to go into astronomy or astrophysics. Now I see in a few masters, but I'm sure there's other ways to get into it.
Okay. Yeah, you know, so the thing about robotics and astrophysics and astronomy, there is a, you know, you have to look at, you know, what your skills are in, you know, computer engineering. Obviously, you understand hardware, you understand software, and, you know, for the most part, you know, you're going to be developing systems. And so the key word here is systems development. All right, so understanding how a system is developed, whether it's you know, robotic systems or computer systems or astrophysics systems, it's important because, you know, if you're going to be developing, let's say, for example, a telescope that's going to be looking out into, you know, space, and I'm not an astrophysicist, but if you're going to be looking into, let's say, exploring the sky with a telescope, well, that telescope is going to require hardware, right? You're going to have a computer control system that's going to be scanning the sky, and then you're going to have software that's it's going to be vital for that astrophysics. So what you have to do is try to tie the you know, your skills as a computer engineer to astrophysics and look at how your skills in astrophysics come together in terms of developing, or let's say pursuing a new career. I would say that for the most part, the you know, the computer engineering is a big benefit, but also the let's say the systems development aspect of it is a huge development, and of course the soft skills, as I mentioned in my presentation. You can't, you got to have those soft skills in order to work with people. I can't tell you how important soft skills are, and yet, and I'm starting to see universities address that, but very slowly. And I took that initiative to learn on my own. And I encourage you to learn more about soft skills.
Perfect. Thank you so much, sir.
You're welcome.
Thank you, George, and thank you, Reynard. I've got a question from Kay.
Hi everyone. Hi George. My question is very simple and straightforward. I just wanted to know, what's the likelihood of being able to transition straight out of a boot camp and into NASA? Is that something that's possible, or do you need to continue building your credentials?
Okay, you said straight out of, oh, I'm sorry, I didn't catch that word.
A tech boot camp. Say you
Oh,
did a boot camp course for
Okay.
about 6 months. Yeah.
Okay. Yeah. Okay. So were you, are you in the United States or another country?
I'm based in the United States. I'm not a citizen. I'm a permanent resident. I also saw some questions in the chat about people bringing up citizenship in alignment with a role at NASA. So I wanted to know if that's, you know, a requirement. Do you have to be an American citizen to work for NASA? Is a boot camp certification in tech or cybersecurity sufficient to enter?
Yeah.
Those are
Okay.
my two
So
questions.
here's my understanding. From what I've learned from colleagues of mine is that if you're not a U.S. citizen, it's you have to. It's a little bit more challenging Not to say that it's not impossible to come work for NASA or for the space industry, SpaceX, Boeing, and some of these other companies. The thing is you have to have a certain visa in order, like, for example, to come work for SpaceX. And, one of the things that is what I found beneficial, especially in the STEM field, is areas that are, let's say, beneficial to the United States. For example, the STEM fields, cybersecurity, software programming, electrical engineering, aerospace engineering. All these are critical, for the United States. And so when they approve I think they call it H-1B visas, they look at what you can contribute to the United States in terms of technology. And so that is a biggie. In fact, I had let's say a mentor from Armenia, and she is now working at the Johnson Space Center as a human factors engineer because of some of the experience that she had when she was in Armenia in terms of human factors. And then she came to the United States, was studying at a university, and got a master's degree in human factors engineering. And I wrote a recommendation letter for her to apply to get her H-1B, and she got it, and now she's working at NASA temporarily, but hopefully she'll become a permanent employee. So there's different avenues available. It's not clear cut, but I have to say that for the most part, there's ways of getting around, to come work either at NASA or supporting contractors. If you come work for a supporting contractor, there's a high likelihood you can eventually come work at NASA. I've seen that somewhere in the vicinity of 25 people in the last several years come work from a NASA contractor to NASA as a civil servant. So it's just a matter of perseverance and being adaptive.
Thank you so much, George. That's very encouraging and informative. I really appreciate knowing that.
You're welcome.
Awesome. Thank you, George. And thank you, Kay, for a great question. And I know there's quite a few people probably in the room today who are going for boot camps, who don't have a degree, and they're asking questions like that. So just like George said, there are huge opportunities joining companies that you want to get to supply chains. And I've recently been speaking myself to some companies like, Airbus and NASA and so on. And there's a huge growing market. And just like George said, if you grow a very crucial skill working for the suppliers of those huge companies, there is a big chance you could get taken on. And another avenue, I've been working with quite a lot of people, just like UK, who completed a boot camp, just 6 months boot camp, no tech background. And the best steps from my observations that people can take to get into space at that stage, while you may not get the specific higher up role in the immediate future, but throughout your program, if you choose to work on projects and build a portfolio geared towards that industry, and you start taking, let's say, a few small courses that would help you bridge the gap between the language or technologies that are used in those specific roles to kind of grow your knowledge in that, then you have a way better chance of getting into those space-related companies. And from there, you start building your experience and so on. So that would be my advice. It's gear up your profile on LinkedIn, become a thought leader on LinkedIn, because what recruiters check out, they do go into your LinkedIn profile and they see what events have you been attending, what have you been posting about, what passions you have. And that right away makes you stand out rather than someone who's got nothing related to it at all. So your portfolio, LinkedIn, and try to get the knowledge, at least to some degree. That would be helpful. in the field. I've seen people, myself, completing a boot camp, gearing up their portfolio for a satellite company, and getting an interview immediately after they graduated from the boot camp. Yeah, because there's a lot of demand. Awesome. If anyone wants to chat more about careers and stuff like that, I posted a link in the chat with my calendar, so book some time. I can talk you through that. Awesome. Dan, I can see you've got your hand raised. Go on.
Yes, thank you. And it is similar to some of the other questions, but on a slightly different track. And I just wanted to say, first off, thank you very much for sharing your story. It's very inspiring. I'm a midlife career path switcher myself, and have spent most of over 12 years in payroll technology and HR technology. And so I'm looking at transitioning into either mission ops or project management, something like that in the space industry. My biggest blocker has been not having finished my bachelor's degree, which I am currently enrolled in finishing now. I'm just interested in, as far as the feasibility goes, either with NASA or an outside space company, both with having a bachelor's degree. It's in space studies, but it's more of a business-oriented space studies, which obviously it wouldn't get me into an engineering role, but might be better for mission ops or something like that. Is that a feasible path? And like you were mentioning, I've been trying to build up some projects on GitHub and presence on LinkedIn as well. I know that was a lot. Sorry.
So the whole area of like say human resources, NASA has quite a few opportunities for human resources. Obviously, we have the big one is what we call the NASA program initiative, if you will, that provides outreach to different industries, countries, and it's all related to human resources. And so it's a little-known area that people never think about. As far as human resources, and actually, there's a lot of different areas that are little known for NASA. That it also includes lawyers, believe it or not. We have a lot of folks that I've been involved with that were patent attorneys, and they came from the law industry, if you will, into NASA. In terms of working, doing patent research and also dealing with other countries. But the area of human resources is one area that I have seen quite a bit of activity, because the NASA has to basically advertise to some extent what they're doing and with industry, but at the same time, if you have project management, let's say project management skills that you have done in some of your prior work, you have to look at and match that against project management that NASA is looking for. For example, there's some project management aspects that are not really associated with spaceflight, but are dealing with, let's say, for example, creating a new human resources group, or let's say, working with industry and managing, let's say, activities with the European Space Agency and things of that sort. So there's a lot of quote project management activities that are associated with human resources, and it's just a matter of looking at USA Jobs, USAjobs.gov provides a great, let's say, opportunity to look at what NASA's looking for in different areas. You just have to basically, become a member and then do a search in terms of what you're looking for. And sometimes you'll come up with some, let's say, opportunities. It's just something that you just have to keep looking for. But not to say that, SpaceX and other companies as well, Blue Origin, as well as SpaceX, are looking for human resource people. You think about it, they're trying to advertise their capabilities. And so, human resources is obviously an area that they, that they also are looking for opportunities and people, to support that activity.
Yeah. Perfect. Thank you very much.
You're welcome.
Thank you very much, Dan, for your question. And George, thank you for taking that. And we've got one more question in the audience. Then we'll have a look at the chat. There will be some questions that we will not have time to address because we have about 11 minutes left. But I'll take those questions and I'll do my best to get back to those questions. And I will also be sharing the recording probably tomorrow. So with that, Riley, would you like to jump on?
Hi, yeah, I'm currently in aerospace major right now, and I'm going to go and get my master's degree, and I don't know if I want to do aerospace engineering or systems engineering. And I was wondering if, as your time as a recruiter, if you found that recruiters were substantially looking for systems degrees rather than aerospace degrees.
Yes. Okay. So, interesting enough, aerospace engineering shows up quite a bit in terms of people that I know that came to NASA and are space engineers. I'd say the majority of the aerospace engineers become systems engineers. In other words, they learn about what it takes to develop a system from cradle to grave. In other words, from the very start of a project all the way to the end. So that means you have to understand requirements development. You have to understand things like architecture development. You have to understand how you're going to verify requirements. Okay, how are you going to validate requirements? What's a good requirement? What's a bad requirement? These are some of the key things that a lot of aerospace companies look for. Now, if you're going to do specific, just straight aerospace engineering, for the most part, a lot of the at least at NASA, as well as some of the commercial companies, they look at people that have experience in guidance, navigation, control. That means, understanding the equations of emotion, understanding Newton's law of motion, and all these kind of things that are associated with guidance, navigation, control. Now, in addition to that, if you couple that with AI, that becomes a big factor, because now if you start looking at developing equations of motion with artificial intelligence, now you're developing sophisticated systems. But then again, going back to what I said previously, is how you're going to verify that that system, if you're going to be using AI, is going to not go south on you later. and so you have to be cognizant of how you develop software that's going to be used for guidance, navigation, control, because that is a critical event, critical operation. Because if that software starts going south on you, that means that your spacecraft can start going in the wrong direction. And so that's the portion of, let's say, aerospace engineering that now is starting to become, let's say, the norm, if you will, is to understand not only the traditional guidance, traditional guidance navigation control, but also couple that with AI and machine learning. But I can tell you that for the most part, a lot of the aerospace engineers that I know eventually become systems engineers and eventually become, let's say, overseeing of major missions, if you will. So I think, but first of all, learn your trade, learn your skills very well, but also soft skills. Learn your soft skills very well, because the soft skills are important.
Okay. Thank you so much. That was really helpful. Thank you.
You're welcome.
Thank you, Riley. Okay, and we've got one more. Ross, jump on.
Hi, thanks. Thanks, Ruta. Hi, George. So my question is, so I have a Bachelor of Science in Mechanical Engineering and a minor in physics, and I'm currently in the automotive industry in manufacturing. But I've managed to get 4 patents by now, and one of them is granted, the other ones are published, but 3 of them are in aerospace engineering. But I realized that I really don't like manufacturing. I want to go into research and development. So what degree do you, I want to pursue a master's, so what do you recommend to masters in?
Okay.
Going
Wow.
to the aerospace industry.
Well, okay, so you obviously have a good solid background in manufacturing engineering, and so in manufacturing engineering, you probably have to understand the quality of the products and how they're going to be manufactured. That's obviously very critical for space applications, because when we're developing systems, we have to look at the parts that are going to go into a spacecraft. Looking at the parts of those spacecraft encompasses not just the, let's say, how it was manufactured, but how it was tested. And so I'm kind of looking at, your capabilities of working in the space industry, if you want to get into the space industry, in terms of what we call, let's see, there's different terms, and I'm trying to use a simple one, electrical parts and mechanical systems research. Okay, so basically what these guys do is that when they're developing, let's say, for example, a spacecraft, as that spacecraft is being developed, you start doing research on the parts that are going to be used for that spacecraft. And you look at the capabilities and limitations of that of those parts based on how they're going to be applied in the application. Because in space applications, you have to look at the environment, understanding the environment. Space environment is very critical. Temperature, pressure, vibration, radiation. Radiation is a huge thing. So understanding the radiation. I can tell you that it just occurred to me that one gentleman that I came to know at a certain company was a mechanical engineer, and he became a radiation expert. Just simply because he started to learn about the materials associated with manufacturing of electronic parts and how that interacts with radiation galactic particles. So something that something that to consider. The whole thing about radiation is starting to become a big issue, not only for space but actually terrestrial. And I didn't realize this, because as things are starting to shrink in terms of electronic components, getting smaller and smaller and smaller, the likelihood of galactic radiation particles, we get bombarded, even though we have the Earth's magnetic field to protect us, we still get bombarded right now as we speak with radiation particles, and those particles can actually disrupt electronic components. So that whole area is something, also to look at. So if you want to get into research and let's say research and development, maybe you want to start looking at the physics of components, the physics of materials, materials processing, materials engineering, and perhaps maybe take you into a direction that may be more interesting for you. Maybe not so much terrestrial, but also for space applications.
Okay, got it. And then what was the name of that role you mentioned for research of materials?
Yeah, basically, let's call it. I mean, different names, but materials and process researcher. So these people, basically look at what materials, what components, what's going to be used in space, especially as we start going deeper into deep space missions, is looking at what's going to be used. Look at those components, look at that material, and do research on that to see what are the, let's say, capabilities and limitations of that are for deep space missions. Radiation, I can tell you, plays a major factor in some of that, and we still don't have a full, let's say, description of every element that's going to be used in deep space missions and how well they're going to perform in a deep space radiation environment.
Okay, that's pretty cool. Yep. So thank you so much. I appreciate it.
You're welcome.
Thank you, Ross. And with that, we're only 1 minute away from the from the half past, and we're gonna have to wrap up. I know there are a few more questions in the chat, so what I'll do, I will take away those questions. I'll try to answer as many as I can myself, and maybe I'll shoot over to George to answer the ones that I won't be able to do. Excellent. Wonderful. So thank you so much, George. I appreciate you speaking to all of us today. You have no idea how much. It's been so wonderful to hear from the person who's been literally for 40 years driving the space industry to such extent like you have. So thank you so much. Also, for those who are interested, me and George, we spoke about another session that George will want to run as well. We're still agreeing on the timing of that, but George actually wrote an autobiography. You can find that online and you can have a little read. It would be really cool if you read that and then came to the event where George is going to be talking about it with some questions prepared. I think that would be a great exercise. And once again, thanks so much everyone for coming. I really look forward to seeing you in our other events. Follow Deep Tech Education, connect with me on LinkedIn, and book a call. Thank you so much, everybody. Bye-bye.